Hey everyone, this is Dr. Walker. This is video 248. It's called magnetic force. The first thing to know about magnetic force is that a charged particle moving through a magnetic field experiences a magnetic force. So, a charged particle like a proton or electron, right? If it's moving and there's some kind of external field there, then that proton or electron will be deflected because it will experience a force. The magnitude of the force, right, the amount of the force, is given by QVB sine theta, where Q is the magnitude of the charge, so just the amount of the charge. V is the speed of the charge. B is the external field. And then we have sine of theta. Now, theta is the angle between V and B. I do have a picture here. So let's say that we have a charge positive Q here, and it's going to the right here, that red arrow. And let's say that it's moving this way, but there's an external field going in the direction of the blue arrow into the page there. Well, you have an angle theta between V and B. And this force that's going to be experienced. Now, this equation is just going to give us the amount of the force. But another thing that we know about the direction of the force is that the force is always perpendicular to the plane containing V and B. So you can see that V and B in this picture are in the yellow plane. So F, the force experienced by the charge, is perpendicular to that plane. Let's do a question. When is the magnetic force on a charge in an external field, and by field I mean magnetic field, when is that force a maximum? So really think about this one and read all of the answer choices. So let's go ahead and eliminate the incorrect choices. So when the charge is at rest, so that one is clearly not good because F is given by QVB sine theta. So there has to be some motion. If the charge is at rest, there's not going to be any force. When the force is perpendicular to V and B, well, as we saw in the previous slide, the force is always perpendicular to V and B. So it doesn't mean that it's going to be a maximum if it's perpendicular. It's always perpendicular. When the charge moves along the field, so along the field means, let's say that B is going this way, then it means that V is going in that same direction. So think about what the angle is. If V is parallel to B, that means that theta is equal to 0. What is sine of 0? Sine of 0 is 0. So if V is parallel to B, then sine of 0 is 0, and that means this whole thing crosses out to 0 and there's no force. So in order for a charge to experience a force, it cannot move parallel to the field. It has to move at an angle to the field. When is the force the maximum? The answer is going to be when the charge moves perpendicularly to the field. Because in that case, if V is perpendicular to B, it doesn't have to be, right? But if it is, then the angle is 90 degrees, and sine of 90 is 1. And 1 is the maximum value that the sine function can take. So, if sine of theta is 1, then that means that the force will be at its maximum value. So that was a lot to take in, so make sure to take some notes and really understand this concept of figuring out what the angle is and how that can tell us if we have a minimum or maximum force. Let's take a look at this example. I added it to this video because it's kind of a quick plug and chug example. It says we have a proton that is moving at this speed 1.62 times 10 to the 3 meters per second, enters a magnetic field of 0.25 teslas at an angle of 43.5 degrees to the field. Find the magnitude of the force acting on the proton. So we just learned that the magnitude of the force is F equals QVB sine theta. And if we picture this problem, we don't know which way the magnetic field is, but let's say that is to the right, then the proton is entering at an angle of 43.5 degrees. That's our theta. That's the angle between V and B. And then we have V is 1.62 times 10 to the third. We have B is 0.25 Teslas. And Q is a charge of a proton. So let's plug in all of our numbers. Remember, the charge of a proton is E, which is 1.6 times 10 to the negative 19 coulombs. And then V is 1.62 times 10 to the third. And then B is 0.25. And then we multiply that by sine of 43.5. Make sure that your calculator is in degree mode for all of this. And you multiply all of that, you're going to get 4.47 times 10 to the negative 17 Newton. So this was just a quick plug and chug to find the amount of the force. In the next video, we're really going to focus on how do we find the direction of that force. I'll see you then.